Hello Algebra 2 students. This video will cover Regent questions from Unit 4, Sequences and Series. Each section is a different standard that the Regent could test you on pertaining to, again, sequences and series. So, question 1, sequences. We're given the ninth term, f of 9 is -2. Which function can be used to generate this sequence? We have to try to find a pattern. So, in order to determine a pattern, you're most commonly going to be getting arithmetic or geometric. So let's check if this is arithmetic or geometric. First, I'm going to check for a common difference. If there's a common difference, you're going to take a term and subtract it from its previous term. I wrote that one a little too big. So, we could take -7.25 and subtract -8. And I get 0.75. Now we have to check if it's a common difference. So take another term and subtract it from its previous term. And we get the same difference, so it's common. That's a common difference, which implies arithmetic. Your arithmetic sequence formula, which is on your Regent reference sheet, is a sub n equals a sub 1 plus n minus 1 times d. Your first term is -8. Let's leave the n abstract, right? Because we want to be able to plug in any number per term. And then the common difference was 0.75. Now, this looks very similar to our answer, but there's a minus sign and not a plus sign. So they tried tricking you there. You got to be careful of that. Really look at each answer choice. So, this one clearly isn't right. So we're going to have to distribute out. So we distribute out the 0.75. And then combine like terms. So -8 minus 0.75 is -8.75. And that's your formula. Something else that you could do if you don't feel comfortable doing this, you could just plug in. So if you plug in 9 into any of these, you should get -2. You plug in 1, you should get -8. You plug in 2, you should get -7.25. You plug in 3, you should get -6.5. Right? So that's something else that you could do. A recursive formula. All a recursive formula is it shows a relationship between a term and a previous term. So it really does, if it's geometric, you're going to show common ratio, multiplication. If it's a arithmetic, then it will show common difference, addition. But for a recursive formula, you must always remember, include the first term. You won't know where to start if you don't include the first term. Now we have to find some sort of relationship between that first term and between a term and the previous term. So, I mean, this one is kind of obvious to see. It looks like you're multiplying by 1/2. So, there's a common ratio. You would take a term and divide it by its previous term. So 9 divided by 18, same as 4.5 out of 9, which is all just 1/2. Since it's a common ratio, you know it's multiplication. So that would be the recursive formula. That is option 1. Okay. You are given the first term, and it shows a relationship between a term and a previous term. So that is a recursive formula. And remember what I used to say when I was teaching this. Recursive formulas are annoying because you have to take it term by term. You can't just plug in 3 and get your answer as you would with an explicit formula. So, start with the first term, and then you go to the next term, a sub 2. We're going to plug in 2 wherever I see n. Let's just simplify that. A sub 2 minus 1 is 1, plus 2 plus 1 is 3, 2 minus 1 is 1. A sub 1, we said was 8. And then, if we're evaluating that log, you could put it in your calculator. You don't have to do this on your own. But you know that this is the same as saying 3 to the 0, because anything to the 0th power is 1. 0 divided by 1 is 0. So 8 plus 0 equals 8. Now we see that a sub 2 equals 8. Don't fall into that trap of thinking it's going to stay 8. Alright? So now, finally, for the answer, since we went to a sub 2, we could go to a sub 3. We're going to plug in 3 wherever we have n. Simplify. 3 minus 1 is 2. 3 plus 1 is 4. 3 minus 1 is 2. A sub 2, we said was 8. Put this in common base form if you're doing it not with the calculator. That would be the same as saying 8 plus 1/2. Since when you evaluate a log, it's the exponent of your argument over the exponent of your base. Again, you don't have to do this by hand. You could do this in your calculator. Answer is number 2. Okay. Which pattern is geometric? If geometric, we know we're looking for a common ratio. So, let's check. I'm taking a term, dividing it by its previous term. Negative 12 divided by 16 is negative 0.75. 9 divided by negative 12, negative 0.75. They all equal negative 0.75, which indicates that number 1 is geometric. But let's look at these other formulas. What kind of sequences are these? 1, 4, 9, 16, all perfect squares. And it starts at 1, so it would be n squared. That would be this sequence. Let's check if this has a common difference. 18 minus 6 is 12. 30 minus 18 is 12. So that's arithmetic. You could use your arithmetic sequence formula to find that one. And this one is actually, it's a fraction, and the numerator is arithmetic, the denominator is arithmetic. So you could treat them accordingly, right? N for number 1 would be n, right? So that would be, for the second term, you plug in 2, you get 2. The third term, you plug in 3, you get 3. Here, it starts at 2 and it's going up by 1. So n, if you plug in 1, you'd get 1, so not 2. So in relation to 1, how do you get 2? It would be plus 1. So then for the second term, plug in 2, and you get 2 plus 1, which is 3. So that would be this formula here. After Roger's surgery, his doctor administered pain medication in the following amounts in milligrams over 4 days. How can this sequence best be modeled recursively? Typically, medication in your body exponentially decays. So let's check that out. Let's see if it actually is geometric. Take a term, divide it by the previous. Take another term, divide it by the previous. I got 0.84. Let me check the other one. 0.84. DL equals 0.84. So the amount of medication that remains in the body after a day would be 84%, right? Common ratio. How can this model be modeled recursively? Remember, you have to show the first term. The first term is 2,000. Now you want to show a relationship between a term and its previous term. What's happening? You're multiplying by that common ratio of 0.84. So we have to look for something very similar to that. Looks like that would be 3. Okay. At her job, Pat earns $25,000 the first year and receives a raise of $1,000 each year. The explicit formula for the nth term of this sequence is as follows. As you can see, it's arithmetic, right? Because you're going up by 1,000. And they used a sub n equals a sub 1 plus n minus 1 times d to create that formula. Which rule best represents the equivalent recursive formula? So, for the recursive formula, you must state the first term, a sub 1 equals 25,000, and then you want to show a relationship between a term and the previous term. It's going up by 1,000 each previous term. So we're looking for this answer. A sub 1 has to be given, and a sub n minus 1 plus 1,000. Very good. 3. Okay. The amount of money the company saved over 5 years following the loss of employees is shown in the table below, which determines the total amount saved. Just from looking at this, I could see that this is going to be geometric. This is your geometric series formula, right? So let's just make sure it's geometric. R equals a term divided by the previous. So let's just check that that's the same. You end up getting common ratio of 1.1. So first let's focus on sigma notation. We know sigma just means you're adding up all the terms of this sequence, so you would plug in 1, and then you would plug in 2, you would add it with exactly that, but plugging in 2, and add it with exactly that, and plugging in 3, all the way to 5. So typically you want to try to use the geometric sequence formula to create that rule. So that's a sub n equals a sub 1 times r to the n minus 1. First term is 59,000. Common ratio 1.1 to the n minus 1. Sigma, since it's the sequence formula, you start at 1, and it's for 5 years, so you go to 5. Let's see if any of those match that. This is 0.1, so we could cross that out. This is not to the n minus 1, so you could cross that out. So, they didn't give us the correct sigma notation. But something that's on the Regents reference table is your geometric series formula, which is the same thing. A sub 1 minus a sub 1 times r to the n over 1 minus r. First term is 59,000. Common ratio 1.1 to the n over 1 minus, n is 5 in this case. The series is to 5. So the one that matches that is option 1. Okay. Kristen wants to increase her running endurance. According to experts, gradual mileage increase of 10% per week can reduce the risk of injury. If Kristen runs 8 miles in week 1, right, it's growing, so it would be 1.1. And in week 1, it's a 6-week program, so it would go to 1.1 to the 5th because that counts. So let's see which one would count. This is geometric clearly, so a sub n equals a sub 1 times r to the n minus 1. First term is 8, common ratio of 1.1 because it's growing by 10%. And then to the n minus 1, that's the sequence formula. In order to turn this into a sum, you do sigma, start at 1, and then it's going to go to 6 weeks, so to 6. And imagine this. Imagine you plugged in 6. 6 minus 1 is 5. That's why it goes to 5. Does that match 1 to 6? 8 times 1.1. Yeah, that matches. Answer is 1. Let's just, for kicks, use our geometric series formula. So a sub 1 would be 8 to the 6. Does that match? No, because it's 0. It's also n. 1 minus 1.1 actually is negative, right? 0.9? Still not the same. Yeah, no. That's negative 0.1, so it's not even close. But, regardless, we already had our answer. Question 9. A ball is dropped from a height of 32 feet. It bounces at a rebound of 80%. I'm just going to do 32 times 0.8. 25.6. Okay, so we see what's happening here. What is the total downward distance in feet? So down is 32, 25.6, 20.48. So that is a sequence here. It's geometric because you have a common ratio of 0.8. So there's two things you could do. You could use your geometric series formula up to the 12th bounce. So S sub 12 equals A sub 1 is 32. Common ratio we said was 0.8. To the n is 12 because we're going to the 12th bounce. That will give you an answer. So make sure you put that in parentheses, that in parentheses. If you're putting the whole thing in your calculator at once, 32 minus 32 times 0.8 to the 12 divided by 1 minus 0.8. You end up getting 149.00488837, so it's about 149. Something you could do to try to check your answer, you could use summation notation as well. you would use your geometric sequence formula to create the rule. First term is 32, common ratio 0.8 to the n minus 1. You're using a sequence formula, so start at 1, go to 12, put the rule. If you have a TI-84 plus CE or a TI-84, you will be able to do this. You go to math, go to summation, type in x for n, 1, go to 12, type the rule in 32 times 0.8 to the x minus 1, and you end up getting the same exact answer. Okay? You didn't have to do all of that work though. You could have just left it there. And I recommend leaving it there because that is a formula that's given on your Regent reference sheet. Okay, first term of a geometric sequence is 8. Fourth term, so second, third, fourth term is 216. What is the sum of the first 12 terms of the corresponding series? So let's think about this. You're going to multiply by a common ratio, multiply it by a common ratio, multiply by a common ratio. You're multiplying 8 by r 3 times to get 216. You could, by the way, you could also use your geometric sequence formula, and you're going to end up in this exact same equation. Divide by 8. Take the cubed root of both sides, or the 1/3 power, right? You get r equals 3. Found your common ratio. Now we could use our geometric series formula. Again, this is provided on your Regent reference sheet. So, S sub 12 was the first 12 terms, equals the first term is 8, minus 8 times 3 to the 12 over 1 minus 3. If you're doing the whole thing in your calculator, put parentheses around the numerator and the denominator. To the 12 divided by 1 minus 3. You end up getting 2,125,760. Okay, and that's it. Hope this helped. Thank you.